Welcome to the DIY Honda Garage channel. Welcome to this diagnostic troubleshooting guide for DTC P0480, which signifies an RFC, radiator fan control system, malfunction in the Honda Civic models from 2016 to 2021. The significance of this DTC code relates to the radiator fan assembly, which plays a crucial role in regulating the engine temperature. When this malfunction occurs, it typically indicates that there is an issue within the electrical system of the fan or the related control components. Being informed about the error helps in effective troubleshooting and efficient repairs of the vehicle. The aim of this presentation is to walk you through an organized troubleshooting approach to diagnose and resolve the issues related to the P0480 code. DTC P0480 describes a malfunction in the RFC system, which directly affects the radiator fan's functionality. The radiator fan plays an essential role by cooling the engine and the radiator, thus maintaining optimal operating temperatures. It operates under the control of the PCM, which refers to the Powertrain Control Module, and the RFC relay. This relay acts as a switch to power the fan when necessary. The fan assembly is typically located at the front of the engine bay, behind the radiator. If there's an RFC system malfunction, it could lead to the engine overheating and potentially damaging engine components. There are several possible causes for the P0480 DTC, starting with poor electrical connections among critical components like the RFC unit and the PCM. Loose or corroded connections can lead to inconsistent performance or total failure of the radiator fan. Another common issue could be a faulty RFC relay, which can stop the fan from receiving the necessary electrical signal to operate. Additionally, damaged wiring within the harness that connects these components can also contribute to this error code. Each of these components need to be meticulously inspected to identify the root cause of the malfunction in the RFC system. The symptoms associated with DTC P0480 include potential engine overheating, as the radiator fan may not be functioning correctly. This overheating can trigger warning lights on the dashboard, alerting the driver of an urgent issue. Another symptom is that the radiator fan may fail to operate altogether, which can lead to increased engine temperatures over time. Furthermore, during diagnostic checks, expect to see unexpected DTC readings, which might confirm the presence of errors linked to the RFC system. These symptoms serve as critical indicators that signal the need for immediate troubleshooting to avoid further damage to the vehicle. For troubleshooting DTC P0480, the first step is to ensure the vehicle is in the on mode without starting it. This enables the various diagnostic systems to initialize. Use the HDS, which stands for Honda Diagnostic System, to clear the current DTCs. Once cleared, navigate to check for any pending or confirmed DTCs again using the HDS. If DTC P0480 still appears, it indicates that the problem persists and the failure must be duplicated in the next steps. If the DTC does not reappear, this may suggest an intermittent issue, warranting a closer examination of electrical connections and terminal integrity. After confirming the presence of DTC P0480, the next troubleshooting step involves visually inspecting the fan shroud assembly. Begin by turning the vehicle to the off lock mode for safety. Look for any physical interference with the fan shroud, such as debris that could obstruct the fan's movement. Additionally, check for ice accumulation on fan blades during colder seasons, which can hinder operation. Assess the condition of the radiator fan and the fan shroud itself for any broken or deformed parts. Any detected issues should be repaired or replaced before proceeding to the next diagnostic steps. The third step is to check the fuse linked to the RFC system, specifically fuse number A13. which has a rating of 50 amps. Its location is within the underhood fuse relay box. Therefore, it is vital to have access to this section of the vehicle. A blown fuse would indicate an electrical fault in the system. If the fuse is intact, you can proceed with further checks. However, if the fuse is blown, replacing it may resolve the issue temporarily, but it would be essential to identify what caused it to blow in the first place prior to replacement. In this step, start by removing the brown number A1350A fuse along with the RFC relay. Once these components are disconnected, continuity must be checked between specified test points. This step focuses on determining whether there is a short in the plus B RFC wire, the wire providing power to the RFC relay. Ensure that the vehicle is in the off lock mode and that the RFC relay remains disconnected during this process. If continuity is found, the wire is shorted and will require repairs. If intact, it suggests that the wire itself is in good condition, allowing you to proceed to the next troubleshooting step. The fifth step involves disconnecting RFC unit connector A, which is a 2-pin connector, to perform continuity checks between the RFC relay and specific test points. Taking these measurements will help determine the integrity of the RFC driver RLY outwire, which connects the RFC relay to the RFC unit. As before, ensure that the vehicle is in the off-lock mode to ensure safety during testing. If continuity exists, it indicates that there is a fault in the wire that must be repaired. If there isn't continuity, that points to no issues in this wire section, and the troubleshooting process continues. For Step 6, testing the RFC relay is essential, as the relay is a critical component in controlling the fan operation. This test checks whether the RFC relay is functioning correctly. If the relay is operational, then the next step involves replacing the number A1350A fuse and rechecking the system. However, if the relay fails the test, immediate replacement of the RFC relay is necessary to restore proper functionality to the radiator fan control system. Monitoring the relay's performance will directly impact the efficiency of the radiator fan operation. The seventh step begins by jumping the SCS line using the HDS to evaluate the system state further. After waiting more than a minute, the next action is to disconnect the PCM connector A, a 50-pin connector that connects the PCM to the vehicle's wiring. It is essential to measure the voltage between specified test points at this juncture, ensuring the vehicle remains in off-lock mode. A successful reading of battery voltage indicates proper connectivity through the system, allowing you to move forward with diagnostics. If no battery voltage is detected, the troubleshooting will shift focus to potential issues in the wiring connecting to the PCM. At this point, the process involves removing the RFC relay again and checking for continuity between the RFC relay's terminal and the PCM. Make sure the vehicle remains in the off-lock mode while testing. If continuity is detected, it implies the RFC RLY CL wire is functioning as intended. If not, it suggests an open circuit in this wire. The lack of continuity necessitates a repair to this wire to restore the necessary communication within the RFC system. Ensuring proper signals are received from the PCM is vital for the reliable operation of the radiator fan. Step 9 requires retesting the RFC relay to ascertain whether it is functional post any previous repairs or checks. If found to be in working condition, the troubleshooting can progress to further steps. However, in the event that the RFC relay is deemed faulty again, a replacement becomes necessary to ensure proper signaling and operation within the radiator fan control system. This is a crucial step as the relay's functionality directly influences the radiator fan's operation, and by extension, the engine cooling system. For the 10th step, the focus shifts to checking fuse number A5, rated at 5 amps, located in the underhood fuse relay box. As with previous fuses, any indication of a blown fuse requires immediate replacement to restore power to the necessary components within the RFC circuitry. If the fuse remains intact, it indicates that the associated wiring is functioning correctly, and troubleshooting can continue to the next step. It's important to keep a close eye on the fuse's condition, as frequent blowouts may indicate underlying electrical faults requiring further investigation. Step 11 requires disconnecting RFC unit connector B to check for shorts in the fan control line between the programming control module, PCM, and the RFC unit. This check is vital to ensuring that there are no electrical shorts that could impair connectivity. If shorts are confirmed, repairs must be carried out to restore proper electrical flow between these components. If the electrical checks locate no issues, it indicates that the fan control wire is functioning properly, allowing you to proceed in the troubleshooting process toward additional checks. In Step 12, continuity checks are once again required, but this time focused explicitly on the fan control line. Ensure the continuity test is performed with both the PCM connector and the RFC unit connectors disconnected. This method guarantees that no external factors disrupt the test results. If continuity is absent, it suggests an open circuit that would impede effective fan control operation. In such cases, immediate repairs are necessary to rectify the issue in the fan control line, enabling the proper functioning of the radiator fan system. Step 13 involves yet another removal of the RFC relay, but with the intention of measuring voltage to the RFC relay from the power source. This requires the vehicle to remain in the off-lock mode. Check the voltage between identified test points to ensure that electrical power is reaching the RFC relay. If battery voltage is detected, this indicates that the line is operational and further checks may proceed. However, if voltage is absent, this points directly to an open circuit in the +B RFC line, which must be repaired without delay to restore the functionality of the RFC system. In the 14th step, conduct a final test on the RFC relay following any previous electrical checks or repairs. This ensures the relay's operational status is confirmed prior to finalizing troubleshooting. If the relay is determined to be functional, the process can advance without further actions required pertaining to that component. If it exhibits any issues, immediate replacement of the RFC relay is necessary. Its performance is paramount, as it directly controls the operational state of the radiator fan, critical for engine cooling. Step 15 involves reinstalling the RFC relay and reconnecting the PCM connector A to restore all connections made during the diagnostic checks. The next step is to exit the SCS mode with the HDS to initiate the normal operating mode for the system. After completing this process, turn the vehicle to the on mode to prepare for checks. The ultimate goal of this step is to check for any pending or confirmed DTCs with the HDS again. If DTC P0480 still appears, it indicates ongoing issues in the RFC system, requiring further investigation into potential unknown faults. In the 16th step, we focus on the GND, ground lines functionality, which is essential for the complete operation of electronic systems in the vehicle. After turning the vehicle to the off-lock mode, perform continuity tests to ensure a solid ground connection between the RFC unit and the G402 ground point. Rather than assuming all connections are secure, this step focuses specifically on confirming integrity in the grounding system. Absence of continuity would signal a broken or compromised ground connection that requires immediate attention. Ensuring proper grounding is essential for preventing electrical failures that can affect the RFC system. The final step introduces a substitution method to conclusively test the RFC system integrity. To do this, a known good RFC unit is obtained and installed into the vehicle. Once the substitutions are made, carefully reconnect all relevant connectors to ensure no additional issues arise from disconnection. Clear the DTC using the HDS and then check for any pending or confirmed DTCs once more. If DTC P0480 appears again, further research must be undertaken for any additional service information or authorized solutions. If replacing the RFC unit resolves the issue, it confirms that the original RFC unit had failed. After completing all the outlined troubleshooting steps and repairs for DTC P0480, the final repair verification process is crucial. Begin by confirming that all repairs made have indeed resolved the issue, particularly noting if the DTC reappears. Conduct functional tests of the radiator fan to ensure it operates correctly under various conditions. Check for any recurrence of DTC P0480, ensuring the system operates without error after repairs. Successful verification concludes the troubleshooting process, proving effective rectification of the RFC system's malfunction. To prevent issues related to DTC P0480 from resurfacing in the future, regular maintenance is strongly advised. Start with periodic checks of critical electrical connections, ensuring they remain tight and free from corrosion or debris. Inspect fuses and relays regularly, replacing any components that show signs of wear or damage to avoid disruptions in operation. Additionally, maintaining the overall cooling system through regular coolant changes and ensuring no obstructions in the radiator or fan assembly is key to system longevity. By implementing these preventive measures, the risk of future malfunctions in the RFC system can be minimized considerably. In concluding this presentation on DTC P0480 pertaining to the Honda Civic from 2016 to 2021, it is vital to reiterate the importance of following systematic troubleshooting steps. Each diagnosis should be thorough, acknowledging each component's role within the RFC system. Conducting careful inspections to uncover potential faults is crucial for an accurate diagnosis. Any components found to be faulty must be replaced to ensure the proper functioning of the radiator fan assembly and, ultimately, the engine cooling system. By adhering to these guidelines, technicians can effectively address and resolve issues related to DTC P0480, thereby enhancing vehicle performance and reliability. Please like and subscribe to the channel. See you next time.